Hi guys, welcome to 2.2 polynomial functions of higher degree. Today we are going to focus on objective 3, which is finding and using zeros of polynomial functions as sketching aids. I am going to go back and review a little bit what was in 2.2 part 1. So first I want to talk about the leading coefficient test that can be used to determine the end behavior of a function. So the leading coefficient and the degree are important pieces of any polynomial. The degree is going to be the highest exponent on a variable. If it's in standard form, it will be first, but sometimes they try to trick you up by putting it in a different spot. So this one has a degree of 2, and the degree is even. When your degree is even, it tells you your ends go in the same direction. Your ends are going to go in the same direction. Okay, so then I'm going to go ahead and look at that leading coefficient. And you're going to ask yourself, is it positive or negative? The leading coefficient always represents the right hand behavior. The right hand behavior. If it's positive, it goes up. If it's negative, it goes down. So let's just draw a general sketch of what we look like, what we think A is going to look like. The ends go in the same direction, and it's telling me on the right-hand side, since it's positive, my right-hand side is going to go up, and since it's an even degree, the other end, the left-hand end, has to go in the same direction. It's also going to go up. So it's going to look something like this. Now, what is all of this nonsense right here? I'm going to show you what this means. As x goes to positive infinity, this is just saying as x goes right, what's happening? Well, as my x goes right, my f of x, or remember f of x can be thought of as your y value, is going up. I could write up, but in math terms, if it keeps going up, we say it goes to infinity. Now we are going to go ahead and look at this other one right here. It says as x goes to negative infinity, and that is simply talking about when x is going left. So as I follow my graph to the left, you can see my end is also going up. So f of x, or again, my y value, is going up, so that's also going to positive infinity. Okay, so let's look at another one of these. So first, let's find our degree. Our degree is the highest exponent. So our degree is 3, which is odd. When it's odd, it means they go opposite directions. Opposite. Then I'm going to go ahead and look at that leading coefficient. In this case, my leading coefficient is negative, which tells me the right side is going down. Okay, so just to recap, if the degree is even, they go in the same direction. If the degree is odd, they go in opposite. If the leading coefficient, the green piece, the number being multiplied by the variable is positive, it means your right hand is going up. If it's negative, it means your right hand is going down. So let's draw a sketch. Let's start with our right hand behavior. The right hand side we said is going down. And because it's an odd degree, that means my left hand side has to go in the opposite direction. It's going to go up. We haven't talked about what's going on in the middle, but we will today. So let's go ahead and fill in this piece. If as x goes to positive infinity, or as it goes to the right, as x goes to the right, I'm going down. And instead of down in math terms, we write negative infinity because it's going to keep on going down. When I look here, as x goes to negative infinity, or as we said, as x goes to the left, f of x is going up. So we're going to write it's going to positive infinity. Okay? I'm not going to do any more of these. I just wanted to review that with you. I also want to review this with you, similar to what we just did. Let's look at C. People get confused because it's got a decimal in there, but it doesn't change anything. Okay, in fact, we're not even going to look at this. This one, we're going to go directly from the graph. So as x goes to positive infinity, which is talking about as x goes to the right, my graph is going up or to positive infinity. As x goes to negative infinity or to the left, my graph is also going up. And let's look back and double check that this makes sense. The degree is even, okay? So the degree being 4 is even. That means my ends should go in the same direction. They do. My leading coefficient is positive, which means my right-hand side should be going up, which it is. Now, why did I review all of that? Because notice the only thing this tells us is about what's going on at the ends of the function. We want to talk about what's happening in the middle, okay? So there are some important things on here that you want to write down. If you need to, go ahead and pause the video. We're going to talk about zeros, roots, and solutions. And we've talked about these before. This is where my solutions are, but excuse me, on a graph, it's where it crosses the x-axis or it's the x-intercepts. And more specifically, since I'm on the axis and I don't move up or down, the y value equals 0. Now, these two things are important, and you should memorize these, okay? A polynomial function may have up to n real zeros, where n represents the degree of a polynomial. So for an example, if I gave you this polynomial, 3x squared minus 5x to the fourth plus 2, we would have to identify our degree. And remember, it's not always the first exponent. It's the largest exponent. So my degree would be 4. So we could say the degree is 4. And what this tells me that I may have up to, which means I don't have to have 4 zeros, but I could have up to 4, but no more than 4. So up to 4 zeros. So what that means is I could cross my x-axis potentially 4 times. Okay. And then the next one here talks about a polynomial function may have, and again, may have mean you can have up to, but not more than, may have up to n minus 1 minimum or maximums where n represents the degree of a polynomial. So what are they talking about? Well, here is what they're talking about. Let's just kind of look at this last example I gave you. So let's make some notes. The leading coefficient is 3, and it's positive, which means my right-hand side is going up. Okay. Then I'm going to look at that degree, which we already said in the last one is 4. When the degree is even, it means ends are the same. Exactly what we just reviewed. So here's what I know so far. I know my right-hand side goes up, and I know my ends are the same, so my left-hand side must also go up. What it doesn't talk about here, and let me just change the color on this so we don't get it confused with the axes. What it doesn't tell me is how many times it crosses the x-axis. But I know I can have up to 1 less than the degree. So if my degree is 4, that means I can have 3 mins or maxes, or up to. So if I finish this, it could, if it had all 3, and this corresponds with the zeros. Remember, the zeros are where it crosses the x-axis. So if I just made these random ones here, my graph could look something like this, okay? And you could see it has the 4 zeros right here, and I'm going to highlight those for you. So again, 4 zeros. Those are your zeros. But I could also have up to 3 minimums or maximums. So minimums or maximums are the top or the bottom of your hills. So here, I could have up to 3. I could have less than that. Let me show you an example with still having the same end behavior. So if we have a graph like this, my ends would still have to go to the right. And maybe this time I only have 3 zeros, because remember, it's up to 4 zeros. Okay, so maybe this one looks like this. Okay, now let's look. How many zeros do I have? 1, oops, I did the wrong color. 1, 2, 3. And then how many, oops, trying to get this green that I made there go away. There we go. So we've got my 3 zeros. And now let's look at how many minimums and maximums. I'd have 1, 2, 3. I would still have 3. But again, all that works. Okay, so why are we learning this? Well, here's an example. We're not going to use a graphing calculator. We are going to graph this one by hand. So let's get rid of that. That is not what we wanted to say. We're just going to say graph the function. Okay? And it says, and approximate any real zeros and relative extrema. And we're not going to worry about the relative extrema. We are simply going to learn to graph this. The first thing that you want to do is identify the degree. And we know the degree is the highest exponent, so the degree is 3. Okay, the leading coefficient, which we shorthand for LC. There's nothing here, but we know there's a 1 that we don't see, so I'm just going to write positive. Let's think about what that means for our ends. If it's got a degree of 3, that means my ends, remember it's odd, so ends are opposite. Okay, but the leading coefficient of positive tells me the right-hand side goes up. So I don't know where yet, but we're just going to say it goes up right here for now. And the other end has to be the opposite according to the degree. So I know this is what my ends would look like, but I don't know where any of those zeros or anything important in the middle is. So we're going to go back to factoring from last section here and actually solving this. So the original equation is f of x equals x to the third minus x squared minus 2x. First of all, you change f of x to 0 because that's your y value, and we're going to solve this. But we can't factor this right away because we only learned to factor x squared problems. But hopefully you'll notice that I can factor out an x because there is an x in each term. When I take an x away, I'm left with x squared minus x minus 2. Now, referring back to factoring from the last lessons, I'm going to go through this quickly. The 0 and the x don't go anywhere. My options for 2 are only 1 and 2. It needs to be negative. That means one of these has to be negative. If you look at the sign on B, that's going to be the sign of the bigger number. So our bigger number is 2, so we're going to make that negative. And this makes sense. 1 minus 2 is going to equal negative 1, or that B value. And 1 times negative 2 gives me that negative 2 that I need. So now I can factor it. Since I just have x squared, it's x and x. I'm going to put 1 as plus 1, and the 2 is negative, so minus 2. Now that these are all factors, meaning they're all just being multiplied and set equal to 0, I can take each one separately and set it equal to 0. Okay, if I solve this by subtracting 1, I get x equals negative 1. If I add 2 here, I get x equals 2. So I have 3 zeros right here. And remember, this is going to tell me where my graph crosses the x-axis. So I know it's got to cross at 0, -1, and +2. Okay? So let's go ahead and draw in that graph. Obviously, I'm going to have to move these a little bit, but the ends aren't going to change. They just have to come a little bit closer together. So, oh, I don't know why it keeps writing when I try and move that. Give me a second here. There we go. Now, let's go ahead and draw in that shape. Now, we didn't talk exactly about what the minimums and maximums were. We're just drawing a general sketch. Okay, that's just a general sketch. Now, I do want to show you what the actual function looks like in Desmos, just so we can compare. Okay, so what I'm going to do is take this over here. Let's go to desmos.com. Okay, desmos.com. Oh, no, I don't know what the computer is doing there. Let's try again. Desmos.com. And I am going to just put this equation in for us very quickly here, just so we can kind of check it out. Desmos is a great tool if you want to use it to check your work. It's not cheating as long as you do it first. And sure enough, my graph is pretty darn close. And yes, in Precalculus, we will be using the graphing calculator, but I should also have a general idea of what my graph is going to look like. Okay, so let's go ahead and just do one more of these so you can get an idea of what it looks like. Okay, let's go ahead and look at this one. So it's just kind of walking you through the steps here. You can see I have 1 and 2. Let's determine that degree. So the degree is, actually, let's skip to this one. The degree is 4, which means my ends go in the same direction because it's even. My leading coefficient is 1, which is positive, which means my right-hand side goes up. So my right-hand side goes up, and because my ends are the same, my left-hand side is also going to go up. Okay? Now, this one may look challenging to graph, or to factor, excuse me, once we go to find these zeros. But when you have x to the 4th, you can treat it just like x squared. And I'll show you the only difference in the end. So if I go to factor this, since a is 1, it's an easy one. I can just look at that end term. My factors of +4 are 1 and 4 or 2 and 2. Now, you have to take the sign on b. That has to go with the bigger number. It's negative. So here, and if they're the same, just make one of them negative. But a negative times a positive does not give me a positive. So these other ones have to be negative too. So let me recap. I used the sign of b on the bigger number. Then I said, well, a negative times a positive would not work because my 4 has to be a positive. So they both had to be negative. And now I do the math. -1 minus 4 is -5. -2 minus 2 is -4. And I'm going to pick the one that equals my b term. So what's the difference? Because now I'm factoring with an x to the 4th. Well, instead of x times x, it's going to be x squared times x squared, because x squared times x squared gives you x to the 4th. And I'm going to go ahead and plug in this -1 and -4. Now that they're being multiplied and equal to 0, I can take each one and set it equal to 0. Okay, let me see if I can't move this or is it locked. Give me 1 second here. Well, we're just going to work around that. That will be fine. So I add 1 to each side. To get a square, an x that's being squared alone, you take the square root of each side. Here's the part people forget. When I take the square root of a variable squared, my answer is both the positive and negative solution. Let's do the same over here. If I add 4 to each side, I get x squared equals 4. And again, take the square root, and it has to be both the positive and the negative. So I know that I'm going to cross the x-axis at 1, -1, 2, and -2. Okay? Let's make sure that makes sense. I have 4 zeros, and it was a degree of 4. That's fine. I can't go over 4. So, how do I do this? Well, we're just sketching these for now. We're not going to plot a few extra points. But if I start up here, I have to cross through that first 0, come back up through the next, back down, and back up. Again, that's a rough sketch of the drawing because I was connecting these. I can make it look a little nicer. But in general, that is what it should look like. And again, if I want to check my work after I do this, I can go to desmos.com and plug in my equation. X to the 4th, get out of that exponent, minus 5x squared plus 4. Hey, kind of looks like my graph. My ends were a little wide, but again, it's a good thing to be able to know what you're looking at. And that is going to be it for today. If you have any questions, I will answer them in class. Please make sure you answer the questions below the video. See you tomorrow.